Hey, welcome back. This is 11.2 on the quadratic formula. So it gives us another method for solving quadratic equations. Okay, so let's just give it to you. Quadratic formula. So you'll have some sort of quadratic equation. And you want the answers to it, and basically all you have to do is plug the coefficients a, b, and c into the following formula, and it'll give you the answers. Okay, so negative b plus or minus the square root of b squared minus 4ac all over 2a, and you have to have that memorized. Okay. So let's take a look here. Solving one of these. This is one we could solve using factoring, and whenever you have a chance, or a choice rather, do factoring. Okay, that's the easiest method. Okay, so it's very quick. Get the answers very quick. Now I'm going to do the same problem, but using the quadratic, just to convince you that it works. Okay. Okay, so I'm going to figure out what a, b, and c are. So a is whatever's in front of x squared. That's 1. B is the 8. And then c is the 12. Okay. Then I'm going to dump them into my formula. I do some calculations in my head, but then others I sort of leave for the next step. So negative b is negative 8 plus or minus b squared. So 8 squared is 64. And then the rest of it I just kind of put in there. 4 times a times c. I'll leave that for later. All over 2 times a. 2 times 1 is 2. Okay. So you see how I did that? I did some of it in my head, but then I leave some of it for later. Okay, so I'm going to go negative 8 plus or minus the square root of 64. And now I'll go ahead and figure this out. 4 times 1 times 12 is 48. All over 2. 64 minus 48 is 16. 2. Simplify. And then we could butterfly that. You have negative 8 halves, which is negative 4, plus or minus 4 halves, which is 2. So our answer is negative 4 plus 2, which of course isn't the negative 2, or x equals negative 4 minus 2, which is negative 6, which is exactly what we got doing it the short way. Okay. So, by no means do I want you to use a quadratic if you don't have to. I'm just trying to convince you that this indeed does work. Okay, it gives you the same answer you get via factoring. So, why do we even bother if it's so long and complicated? It's because of problems like number 5. If you try to factor this guy, you're not going to be able to do it, right? 5 and 4 won't work, 2 and 10 won't work. You're just kind of out of luck, right? I don't know. So in this case, then you pull out the quadratic formula. Okay, you really have no choice. So I'm going to identify my a, b, and c. Okay, so it's x equals negative b plus or minus the square root of b squared, so 3 times 3 is 9, minus 4 times a times c, all over 2 times a is 2 times 1 is 2, negative 3 plus or minus the square root of 9 plus 4 times 20 is 80, and it'll be positive 80 over 2. This would be 98 or 89, sorry. And that would be it. Okay, so yeah, That's why we do it, is because we wouldn't be able to do it via factoring. Okay, let's keep looking at a couple of these. Here's number 9. Unlike completing the square, you don't need to have a leading coefficient of 1, but what you do need is to have everything on one side. You need to set it equal to 0 first. Okay, so you can't have it and say the A is 6, the B is 2, the C is 1. Won't work. You need to move the 2x over, move the 1 over, and then you could set up your A, B, and C. Okay. Then we go to our quadratic. So x is negative b, so negative 2 is 2, plus or minus the square root of negative 2 squared is 4. It's 4 times a times c, all over 2 times a is 12. That'll be 4 plus 24, all over 12. I have a 28 in there, all over 12. We can factor a perfect square out of the radical. 28 is 4 times 7, so I can pull out a 2. I have 2 root 7 over 12. And here you definitely want to simplify, because each term in the numerator, and there's really 2 terms here, have a common factor with 12. Okay, so I can factor out the 2. I'll have 1 plus or minus root 7. Okay, and that's all over 12. And then 2 over 12 is the same as 1 over 6. So you have 1 plus or minus root 7 all over 6. Okay, so you have to simplify. So next question, we'll make the video quiz. Video quiz, video quiz, video quiz, video quiz, video quiz, video quiz. So again, you got to move the 8x over, as well as the 7. Then we identify your A, your B, your C. Okay. Go to your quadratic. X is negative b, so negative 8 is 8, plus or minus the square root of b squared. 64 minus 4 times a times c, all over 2 times a is 6. Let's get a plus or minus the square root of 64 minus 4 times 3 times 7 is 84, all over 6. So I'm getting 8 plus or minus root 20 I, or negative 20 if you want at first. Imaginary numbers are good here. You're allowed to use them. Okay, so we'll have 8 plus or minus 20 is the same as 4 times 5, so you can march a 2 out the front door, march an I out the back door, and then all over 6. Here we can factor out a common factor of 2 in the numerator, but you could also, another way of thinking about this is just the butterfly effect. Okay. So we'd have 8/6 plus or minus 2 root 5 over 6i. I mean, that's your standard form for a complex number anyway, so you want it like that. Then we could simplify. We get 4/3 plus or minus root 5 over 3i. Okay. So you could tell if you're going to get an imaginary answer by looking at the stuff inside the square root. And that stuff inside the square root is called the discriminant. Okay, so the book will make a deal out of analyzing the discriminant in more detail. So the discriminant is basically b squared minus 4ac. And if you look back at the formula, that's just basically what's inside the radical there, the b squared minus 4ac part. Okay, so the solution types based off of that. Because sometimes what you're going to be doing is graphing, and if there's 2 imaginary solutions, it means that the parabola doesn't hit the x-axis, and it helps you draw it quicker. Okay, so anyways, if it's greater than 0, you'll have 2 real solutions. If it's equal to 0, you'll have one real solution. And if it's less than 0, like the last example we did, you'll have two imaginary solutions. Okay. Okay. So it's fairly simple. So for example, number 30, we have 4x squared equals 20x minus 25. They want to know how many solutions and the type of solutions that you're going to get. So first, you still have to move everything to one side. Then we can identify our A, our B, and our C. So b squared, you'd have negative 20 squared minus 4 times A times C. Negative 20 squared is 400. 4 times 4 times 25 is also 400. So you get 0. And in that case, if you look back at our chart up here, there's one real solution. Okay. Okay, so it's nice to know that. It'll help you when you go the graphing, and it'll help you kind of check your answers as well. Okay. This next part is kind of weird, and it's what you're doing is kind of back engineering the original question. So I think the book calls it writing quadratic equations from solutions. I'm just going to call it back engineering. Back engineering equations. Like the UFO technology, they always say they back engineer the UFO technology from the actual UFOs. Back engineering equations. Okay. And you'll do this a lot if you keep taking math. You'll kind of, sometimes you just won't have a clue, but you'll be able to get the answer, and then you can kind of see how they got the answer. That's a way of back engineering stuff. But anyways, first sort of recall how it goes in the forward direction. So we'd have something like x squared minus 2x minus 15 equals 0. And here we're using factoring. We're not even worried about the quadratic or anything. Whoops. So you'd have x plus 3 is 0, so x is negative 3. And then x minus 5 is 0. X equals 5. Okay, so what they're going to do now in the exercises is give you a solution set. Okay, so for example, negative 3, 5. And then what you're going to do is build the original equation. Okay, so how did this work? So we had x is negative 3 or x is 5. Then we could rewrite these as x plus 3 is 0, x minus 5 is 0. Then we could multiply those together. X plus 3 times x minus 5 is 0. So x squared plus 3x minus 5x is minus 2x, and then minus 15 is 0, and we're back to where we started. Okay, so that's the idea. It's just going in reverse. Okay. So let's look at 56. Sure, let's try 52. Negative 2 and 6. Okay, so we have x is negative 2 or x is 6. So we're back engineering. So now x plus 2 is 0, x minus 6 is 0, and then you're like x plus 2 times x minus 6 must be 0. So you'd have x squared minus 6x plus 2x is minus 4x, and then minus 12 is 0. It's pretty simple, right? They'll make it more difficult by throwing radicals in, imaginary numbers, all that jazz. So here we have negative root 3 and then root 3. The neat thing about these is you really don't see the roots in the original equation. Okay, so in the answer you see roots, but not in the original equation. So let's take a look. Okay, so back engineering. Then we can multiply these together and say they both must equal 0. Multiplied together. Then FOIL. Okay, so we have x squared outer minus root 3x, inner plus root 3x, last minus root 9. So you get x squared, these cancel, and then minus root 9 is 3. Okay, so you don't even see the radicals in your original equation. Let's look at one more with imaginary numbers, and then we'll look at some applications, and then go to my math lab. So here's 62. I have 2 plus I, and then 2 minus I. So again, sort of back engineering. Okay, when I move these over, I'm not going to, go minus 2 minus I. I'm going to go minus this whole imaginary complex number. Okay, so x minus 2 plus I. And then the other one, x minus 2 minus I. So then I'll have x minus 2 plus I times x minus 2 minus I. And then I'm going to FOIL those out. So x times x is x squared. Then the outer minus x times 2 minus I. The inner minus x times 2 plus I. And then the last plus 2 plus I times 2 minus I. Distributing, I get x squared minus 2x plus xi minus 2x minus 2x minus xi. Then foiling, I get 4 outer minus 2i, inner plus 2i, last minus I squared. Okay. Get some cancellations and stuff probably. So I have x squared minus 2x. I got the x squared. I got the minus 2x minus, whoops, that's minus 4x then. Xi minus xi 0. And then I get 4, so plus 4. Minus 2i plus 2i is gone. Replace I squared with negative 1. And then finally, x squared minus 4x plus 4 plus 1 is plus 5. And then we have our original equation. Okay, let's look at least one application on number of fatal vehicle crashes per 100 million miles given a particular age. Okay, so this is 77. On page 801 if you want to read it. But they basically give you an equation, f of x equals 0.013x squared minus 1.19x plus 28.24. And f of x represents the number of fatal vehicle crashes per 100 million miles. And x gives the age. Okay. So the question is, what groups expected to be, which groups are expected to be involved in 3 crashes per 100 million miles? So which age groups are expected to have 3 crashes per 100 million miles? Okay, so what are they really asking you to do here? They're asking you to set f of x equal to 3 and then solve for x. Find the age group. Okay, so we'll put 3 in for f of x. Then we have 0.013x squared minus 1.19x plus 28.24. I need to set it equal to 0. And then I could use the quadratic formula. because there's no way you're going to be able to factor that, right? So my A is 0.013, the B value negative 1.19, the C value 25.24. So X will equal negative B, so positive 1.19 plus or minus the square root of B squared, which I don't know off the top of my head, so I'll just leave it like that, minus 4 times A times C all over 2 times A, which I can do in my head. Okay, you're going to get two answers out of this once you go to your calculator. I'll spare you the details, but there'll be one answer will be 58, the other answer will be 33. Okay, so you would expect the 58-year-olds or the 33-year-olds to experience 3 crashes per 100 million miles. Okay, so I'd write that out. The group, the age groups are, geez, that's not a good way to say it. So we suspect the 58 and the 33-year-olds will have 3 crashes per 100 million miles. Seems like I should probably say the 58-year-olds and then the 33-year-olds will have 3 crashes per 100 million miles. Okay. They'll ask you in the software to compare it to the chart and see if it's an under or overestimation, that sort of thing. Let's go and see what they really have for us in the quadratic formula section. Looks like I kind of previewed some of these already. Let's see what we get. Oh, I got rid of some of them. Okay, thought maybe that was a little bit too much. Got rid of that one, got rid of that one. Okay, this is basically just like what I did. Okay, so they want you to set f of x equal to 4.1 this time and solve for x. I got rid of that one. This one looks kind of weird. Let's try this one. So I got square root 2x squared plus 6x plus 4 square root 2 equals 0. So A is square root 2, B, unfortunately my 6's look like B's, 6, and then C is 4 root 2. I guess I'm going to try the quadratic. I'm going to see any other nice way about it. And you try and multiply both sides by square root 2, but you're still going to get a square root 2 on that 6. So let's just do it this way. So x is negative b plus or minus the square root of b squared, which is 36 minus 4 times a times c all over 2 times a. Looks kind of annoying, but I bet it won't be so bad. So yeah, negative 6 plus or minus square root of 36 minus, okay, so we have 4 times 4 is 16. Root 2 times root 2 is root 4. Root 4 is equal to 2. So 32 when all is said and done over 2 root 2. Then you get negative 6 plus or minus root 4 all over 2 root 2. And then I can butterfly it. So you get negative 6 all over 2 root 2 plus or minus root 4 all over 2 root 2. Then I got to rationalize and simplify. Right now it's negative 3 all over root 2 for the first guy. And then 2 all over 2 root 2 for the second. I got to rationalize still. Root 2 on this guy, top and bottom. And root 2 on this guy, top and bottom. Okay. Alright, so I got negative 3 root 2 all over root 4, which is 2, plus or minus 2 root 2 all over 2 root 4, which is the same as 2. And then these will divide out. So you get negative 3 root 2 all over 2 plus or minus root 2 all over 2. And then that simplifies too. So that would just be negative 3 root 2 all over 2 plus, so one answer, negative 3 root 2 over 2 plus root 2 over 2, which is negative 2 root 2's over 2. Just combine the numerators of the common denominator. Negative 3 root 2 plus root 2 is negative 2 root 2's. So that'll be negative root 2. And then, or x is negative 3 root 2 over 2 minus root 2 over 2. So negative 3 root 2's minus 1 root 2 is negative 4 root 2 over 2, which of course is negative 2 root 2. Ugh. Let's see if that will make them happy. Negative square root 2, comma, negative 2 square root of 2. Okay, that one was weird. Ugh, look at this thing. Let's try that. Okay, so this is a rational equation. I got to factor the denominators. I'm not even sure if this is an actual 11.2 problem, but we'll find out. Okay, so what do we have? X plus 4, x minus 1. Really? It's 4, x minus 4, x plus 4. Okay. Right off the bat, there's restrictions we have to worry about from the denominators. X cannot equal negative 4, 4, or 1. So you have to make sure we don't accidentally get one of those as our answers. Once you deal with that issue, then you can get rid of the denominators. So x minus 4, x plus 4, and then we need an x minus 1. Do that on both sides. So on the left, the x plus 4 and x minus 1s will cancel, leaving you with x minus 4. On the right, in the first distribution, the x minus 4's cancel. So you have x plus 4 times x minus 1. Second distribution, you'll just have 2 times the x minus 1. And then we're solving this. FOILing x squared minus x plus 4x is plus 3x minus 4, and then plus 2x minus 2. So x squared minus x plus 4x, yeah. So we have x minus 4 equals x squared plus 5x minus 6, and then 0, bring everything to one side, x squared plus 4x minus 2. And of course that thing won't factor, so you need to use quadratic. So a is 1, b is 4, c is negative 2. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So you get negative 4 plus or minus the square root of 16 plus 8 all over 2. So negative 4 plus or minus square root of 24 all over 2. So negative 4 plus or minus 2 root 6 all over 2. And then we could butterfly it, so get negative 2 plus or minus root 6. And neither of those are restricted, so we're good. Our restrictions were all integers. 2 minus x dash square root 6 comma negative 2 plus 6 Okay, so hopefully that'll get you through it. This is back engineering, one of those. Back engineer. Okay. Okay, that'll be good enough. Thank you for watching, and we'll see you next time.